What, 7 now?
So the first thing says show that this equation has a root, they call it alpha, between 0 and 1. So if I want to check whether there's a root between 0 and 1 of this, first thing I'm going to do is I'm going to find the value of that, and I'm going to find that at 0. So I'm going to put 0 into that equation, and I'm going to find that that's 0 plus 0 minus 1. So if I put 0 in, I get the answer minus 1. Then what I'm going to put in is 1. So I'm going to put 1 into that equation. If I put 1 into that equation, I get 1 plus 3, which is 4 minus 1, which is 3. Now, because there's a change of sign, because I've got a negative there and a positive there, there must be a root between 0 and 1. So it's the change of sign that tells you there is a root between 0 and 1. If you don't get a change of sign, you've made a mistake there, because it's the change of sign you need. When it comes to this next part, you're given this recurrence relation, which is that, with x0 equal to 0.3, and you need to use it to find alpha. They want you to find x1, x2, x3, x4. So we start off, we know x0, so that goes into here as xn. So if I put 0 for n plus 1 would be 1. So to find x1, I'm going to put x0 into this equation, which is 1 minus 0.3 to the power of 4, all divided by 3. That's how I'll find the first value. Plug that in your calculator, because obviously you've got a calculator, and x1 is 0.330633. Use that full display now to find x2. So to find x2, I'm literally going to put my x1 value in here, and then I'll get x2 out. So this will be 1 minus 0.330633 to the power of 4, all divided by 3, which will give me x2 of 0.329350. Repeat that process again. This is where you'll see that this gets rather repetitive rather quickly. Repeat the whole process again. x3 will come out as 0.32941. Do it again. x4, which they've asked for, will come out as 0.32941. Now they want you to find whether that is correct to 5 decimal places or not. So I've rounded this to 5 decimal places. We've got 1, 2, 3, 4, 5. Obviously, there were more on the calculator, but round it. You've now got to prove that that is correct to 5 decimal places. Now, to prove that it's correct to 5 decimal places, you repeat this process we did here with 0 and 1. We go back through that process, but using a number slightly bigger than this and a number slightly smaller than this. So we're going to do slightly bigger than this, which will be 0.329415. So I'm going to round it, go slightly bigger than it, and I'm also going to find then slightly smaller than it, which would be 329405. So I'm going to just go slightly above and below and work those two out. Now those two I work out with the actual equation at the top, not this relationship here we've been given. And then when I type those in, the one that's slightly bigger comes out as 2 times 10 to the power of minus 5, and the one that's slightly smaller comes out as minus 1 times 10 to the power of minus 5. And then again, the change of sign proves that correct to 5 decimal places, that is the answer. Because this one would round up to it and that one would round down. And that is the end of it. It is just a case of just sticking numbers into a calculator, essentially.